Hello, everyone. It is Mrs. Griswold here. We are starting a new unit. We are on Chapter 8, and we are going to do Day 1 today. The title of our notes is Factoring Using the Greatest Common Factor. Our learning targets are I can find the GCF of monomials. We should know what a monomial is. And I can factor polynomials using the GCF. Okay? GCF in both of these situations stands for greatest common factor. Okay, hopefully you've seen greatest common factor before. You've probably done it in middle school, but we're going to refresh our memory just a little bit. Okay, the greatest common factor is the largest number that divides evenly into all of the numbers. Okay, all the numbers that were given. So in the specific example, all of those numbers. So let's look at an example. It says find the GCF between 12 and 30. Now, some of us who have our times tables down really well are going to be able to do these quicker. Some of us, it's going to take a little bit more time, okay? But a way that you can do that helps you if you're not the best with your factors and your times tables, it helps to list all of the factors of each. So I'm going to start with 12. I'm going to think of what are all the combinations that multiply to give me 12, okay? The first one is 1 times 12. 2 times 6 gives me 12. 3 times 4 gives me 12. Okay, those are all of the combinations that I can multiply to give me 12. All right, now I want to look at 30, and I want to do the same thing. I'm going to look at 30. Think of all the things that multiply to 30. I like to start with 1 and kind of build my way up, right? So if I look at 1 times 30 is 30. Now I think about 2. 2 times 15 is 30. Okay, now I look at 3. 3 times 10 is 30. Okay, 30 divided by 4 isn't even, and then 30 divided by 5 is 6. So 5 times 6 gets me 30. And then 30 divided by 7, 30 divided by 8, those are not going to be whole numbers. So those are all of the factors of 30. Okay, so I think about all of the factors of each, and then GCF is the largest number. So I look at all of the list. What's the biggest number that goes into both of these? Okay, I see 6 and 6. Okay, the only bigger number is 12 in 12, and 12 doesn't go into 30. Okay, so then the GCF of these two is 6. All right, so that's one way to do it. You can list out all of those factors, but if you are really quick at your times tables, then you can find that a little bit better. Okay, but make sure it's the greatest, because you see that they both share 2 and they both share 3. But those are not the greatest factors that go in. So again, make sure it's the greatest of all of those. Okay, well, what about variables, right? Monomials and polynomials, they have variables in them, and we actually can find the GCF of those variables. The GCF of a variable is the smallest power between both terms. Okay, now I know this can be a little bit confusing because it's the greatest in one situation and it's the smallest in the other situation, but hopefully when I kind of write these out, you'll see why. Okay, so it says find the GCF between x to the third and x. Okay, well, if we were to expand these and think about factors, kind of like what we did last time, I know that x to the third is x times x times x, and I know that x is just x, and then we have to write it. Now I want to think about how many do they share, right? For this one, we want to think about the middle word in greatest common. We want to think about common. So how many of those variables do they share? Well, they each have only one x in common. Okay, so it's the smallest power between both terms. They both have one x. So the GCF of these two variables is just x. They don't share any more than that, right? Because the one on the right is only an x. So it doesn't have two x's. They only share one x. What is common? Okay, let's look at one more examples of a variable because I know these can be a little bit tricky. I've got y squared and y to the fourth. If it's helpful, again, to write it out as we just start to do these, go ahead. Y squared is y times y. Y to the fourth is y times y times y times y, right? 4 copies. How many do they share? How many do they have in common? I've got 2 over here, matches up with 2 over there, okay? So that means their GCF between y squared and y to the fourth is the smallest exponent that they both share. They share 2 y's, so it's y squared. Okay? Hopefully, as we go on, you'll get a little bit more used to variables and numbers and finding the GCF. Because it might be a while since you've done that. Okay? So let's combine something with numbers and variables. So remember, these are monomials. It's part of our learning target, right? I can find the GCF between 2 monomials. Well, 15x to the third is just one term. That's a monomial. And 9x squared is one term. So that's a monomial. So in order to find the GCF, we're going to do it in 2 steps. The first step is to find the GCF of the numbers. So it wants us to find the GCF between 15 and 9. Okay, again, if you want to think about what multiplies to give me 15, 1 times 15 and 3 times 5. If I want to think about what multiplies to give me 9, 1 times 9 and 3 times 3. Now I look at both of those and I want to find the greatest factor that goes into both. Well, they both share a 3. So the GCF of the numbers is 3. We kind of do these in 2 pieces. Then step 2 is find the GCF of the variables. So the variables that they gave us is x to the third and x squared. So it's the lowest exponent that they both share. If it helps you to expand, you can expand. And then you can visually see, well, how many do they share? 2 in each. So GCF of variables is x squared. They share 2 x's, so it's x squared. So we kind of do it in 2 parts. Look at the numbers, then look at the variables, and then for our final answer, we multiply these 2 together. So I'm going to do this. My answer that you would type into Delta Math, the GCF is 3x squared. Okay, so I like to split it up into different steps because it kind of helps distinguish between the 2 things that we're going to do. But the GCF of 15x to the third and 9x squared is 3x squared. Okay, now let's factor using GCF. So the word factor means a little bit different, right? Find the GCF, we just listed what it was. Okay, factoring the GCF has a couple more spots or steps. So factoring is kind of like splitting the expression into a multiplication of 2 simpler expressions. Another way to describe it is like undoing the distributive property. So we're factoring it out. That's kind of the language that I'll use, factor it out. Okay, so here's example 2. It says factor the expression completely, and those are the directions that you're going to see on Delta Math. So factor the expression completely. So it's very similar to what we just did, but instead of saying 4x squared and 3x, now it's a binomial or a polynomial, 4x squared minus 3x, and how we write our answer is going to be a little bit different in the end. So step one is to find the GCF of all of the terms. Okay, so one term, let me split it up into two. I want to find the GCF of 4x squared and negative 3x. So if it's helpful to kind of split it up, I want to find the GCF of those three. Okay, so remember one thing is GCF of numbers. So the numbers is 4 and negative 3. We think of factors. What number goes into 4 and also goes into negative 3? Well, there isn't anything other than 1, right? 4 times 1 and negative 3 times 1. Then I want to look at the GCF of variables. So my variables are x squared and x. Okay, how many do they share? They each share 1x. So the GCF of the variables is x. So the overall GCF of both of these is 1x, or you don't even need both of those. You can just do x. Okay, that's the only thing that goes in to both of those. All right, but that's not it. That's not what I want to write. I don't just want to write x. Okay, when it says factor, I want to do a little bit more. So what I need to do is I need to divide each term by the GCF. This is the language I'm going to use where I say factor it out. Write your final answer, okay? So it's going to follow this format where we have the GCF, and then in parentheses, we have whatever is left after I divide each piece. Okay, so the GCF that I found that between 4x squared and negative 3x was x. Okay, that's my GCF. Now I need to divide each piece. So what's going to go in this first spot is 4x squared divided by x. Okay, I'm going to take out 1x. What I have left is 4x. Okay, what's going to go in the next spot is a negative 3x squared divided by x. I'm going to take it to x. Now this kind of brings back properties of exponents. If I have 1x on top, 2x's on top over 1x on the bottom, 1 will cancel, leaving me with x on the top. So that's why I just have negative 3x. Okay, and then I close parentheses. So that's how I would type my answer into Delta Math, x parenthesis 4x minus 3x. That's my final answer. One cool thing that we can do is we can check by distributing. So I said earlier that what we're doing with factoring is we're actually undoing the distributive property, right? I said this up here. Undoing the distributive property. So we can redo it and see if it works. So x times 4x minus 3x, and it better give me what I have at the beginning. It better give me 4x squared minus 3x. Oh, I just found a mistake. I wrote it wrong. This is 3x. I'm sorry, this is 3x divided by x. So the x cancels with the x, and what I have left is just 3. I'm sorry, I just caught that. Just found that. That's what happens when you do a video with no students in the room, because I bet one of you would have corrected me on that when you saw that mistake. Okay? So that means when I check, I'm going to distribute 4x minus 3. I'm going to distribute that x in, and I should get what I started with. Okay? So x times 4x is 4x squared. X times negative 3 is negative 3x. Does that match what I got in the beginning? Yes, it does, so I know I did my factoring correct. Okay. All right, let's try another one. Factor the expression completely. This one's a little bit longer. Look, we've got 3 terms. This is a trinomial. So when we're looking at this, we want to find the GCF of all the terms. So this is going to be 10y to the third and 20y squared and 5y. So when we're finding the GCF, we got to look at all 3. So we'll start with the GCF of the numbers. Okay, the numbers are 10, 20, and 5. What helps me find the GCF when I have all these numbers is look at the smallest one and see the factors of that. Okay, the only factors of 5 is 1 times 5. So those are really my only 2 options for GCF to make sure that one of those numbers goes into the other. Okay, well, I know a 10 is 2 times 5 and 20 is 4 times 5. So 5 goes in to all 3. Okay, so the GCF of my numbers is 5. Then GCF of variables. Okay, well, I want to look at y to the third, y squared, and y. What do they all share? Well, if I expand this, how many do they all have in common? Again, just like what I did before, look at the smallest. I can't have more than 1 y in each thing, so they all can share only 1. Okay, so my GCF, the greatest common factor of all 3 of these is 5y. Okay, so that is my final GCF, putting both of those GCFs together. Now I want to write my final answer nice and neat. I have to divide each term by the GCF. So I start by writing the GCF on the outside, 5y. Okay, then each term is going to be found by taking the previous term, 10y to the third, and dividing it by 5y. Okay, so remember with these, I know it's been a couple units, but we should still have this skill. Number divided by a number, 10 divided by 5 is 2. And then y to the third divided by y, I have 3 y's on top. It's going to cancel with 1 y on bottom, leaving me with 2 y's on top. Okay, then my next term is 20y divided by, 20y squared, let me get this right this time, divided by 5y. We divide each piece always by the GCF. So 20 divided by 5 is 4, and y squared divided by y is y. Okay. Lastly, I want to find the GCF of, this one is purple, we need a different color, I'll use red. I want to divide negative 5y by my GCF, which is 5y. Okay, well, negative 5 divided by 5, right? 5 divided by 5 is 1, so it's going to leave me with negative 1. And y divided by y, those are going to cancel each other out, right? A y on the top and a y on the bottom, those cancel. And that would leave me with y to the 0 or nothing. Okay, there's no y left because they both canceled with each other out. Canceled out each other. Canceled with each other out. That was random. Okay, so what I type into Delta Math is this right here. 5y parenthesis 2y squared plus 4y minus 1. Then again, you can check by distributing. I'm not going to do that right now. but you could. If you had time and you wanted to make sure that you got it right, you could always check by distributing. Okay? Next example, what if we have multiple variables? Like this expression, 3x squared y plus xy squared. Well, we find the GCF of all of the terms. So just like we find the GCF of, I guess the word pieces, whatever. Just like we found the GCF of the numbers and the GCF of the variables, it's going to be the same, but instead of one variable, now I have two variables. So I'll say GCF of numbers. I've got 3 and 1. So the greatest common factor between both of those is 1. Now let's do GCF. I'm going to differentiate between x and y. GCF of x's. Okay, how many x's do I have in each? Well, one has x squared and one has x. So what's the smallest exponent, or what I can take out of each? Well, I can take out 1x, and that's okay. Then lastly, GCF of y's. Okay, now I have to do this one separately. I have a y on the first one and a y squared on the second one. What do they share? If I were to expand, how many could I share? Well, there's only one. So the GCF, if I wanted to write it, bring this down a little bit. The GCF between both of those, remember, multiply everything now. So 1xy is the greatest common factor in each thing. Now we move on to writing our final answer. So I write the GCF out in front, 1xy, and then in order to get what's in the parentheses, I have to divide each term by my GCF. So the first is going to be 3x squared y divided by my GCF, which is 1xy. Okay, well, 3 divided by 1 is going to stay 3. X squared divided by x is going to leave me with just x. And y divided by y, those cancel each other out, leaving me with nothing left. Okay, next part is doing xy squared divided by my GCF, 1xy. Okay, x divided by x is going to cancel out. Y squared, one of those is going to cancel with the 1 on the bottom, leaving me with just y. So I can write 1y or I can write y, whichever makes the most sense to you. But this is how we would write our final answer. Okay. One last note is you can only factor out a negative if both numbers are negative. Okay, because we've gone through some examples where we have one negative number in all of those, and one negative, and other ones are positive. So if I found the GCF of the numbers, it's -10 and -7. I think of the factors that go into 10 and -7. The only thing that I can really take out is a 1, but they both have a negative, so it's not just going to be 1, it's going to be -1. Okay, I'm not going to finish the rest of this problem because we've already been going for about 24 minutes. I think we have a pretty good grasp. We've seen a good variety of examples. To do the homework, I just wanted to point out that little piece about the negative. One last thing that I want you to do that's going to be helpful for tomorrow, well, not tomorrow, I guess our next class next week, is the X game. So you're going to have some of these on your homework. I think it's kind of fun. But when we do the X game, okay, it says write two numbers that multiply to the value on top and add to the value on bottom. So it's a game. It's kind of like a little puzzle. See if you can figure it out. We want two numbers that multiply to give me 42 but add to give me 13. So I'm going to start off by finding multiples of 42, sorry. 1 times 42 is 42. 2 times 21 is 42. 3 times 14 is 42. And then 6 times 7 is 42. And I think that's it. Okay, now we look at all those factors and we think which one of those combinations added together gives me 13. Well, this one would be 43. This one would be 23. This one would be 17. And this one would be 13. So the winner, the one that multiplies to 42 but adds to give me 13 is 6 and 7. So you can put 6 and 7, you could put 7, 6, either one. Okay? So you're going to see ones like that. Again, if you know your times tables, this is going to be easier. This is going to be faster. If you don't know your times tables, then it's going to take a little bit more work, maybe writing out factors, using your calculator sometimes if you have to. But eventually I think you'll get the hang of it. All right, now you can head over to Delta Math and begin your assignment.